Statements in this presentation relating to Oracle's future plans, expectations, beliefs, intentions, and prospects are forward-looking statements and are subject to material risks and uncertainties. A detailed discussion of these factors and other risks that affect our business is contained in our SEC filings, including our most recent report on Form 10-K and Form 10-Q, particularly under the heading Risk Factors. This presentation is intended to outline our general product direction. It is intended for information purposes only and may not be incorporated into any contract. It is not a commitment to deliver any material, code, or functionality, and should not be relied upon in making purchasing decisions. The development, release, and timing of any features or functionality described for Oracle's products remains at the sole discretion of Oracle.
Please welcome Larry Ellison.
Hello, everybody. Welcome. And recall that at Oracle Open World last fall, we announced the Oracle Autonomous Database. And this is an update on the Autonomous Database now that it's generally available to all of our customers. Okay, so right now, our first autonomous service is available in the Oracle Public Cloud, and it's the Autonomous Data Warehouse. And it became fully available just about a week ago, even though for months our customers have been using it and trying it and moving their data, moving their applications to the cloud. And actually, when I finish with this update, we're going to have a demonstration, and then we're going to have a customer panel, and they can talk about their experiences with the Oracle Autonomous Database. This is a good time for me to talk about our strategy versus Amazon. The Oracle Autonomous Database is the first of several autonomous Paas services we will be delivering this year. Now, everyone knows, and everyone gives rightful credit to Amazon for kind of inventing the market for infrastructure as a service. And they noticed that in a lot of ways, it's more efficient to rent computers than to buy computers. So Amazon pioneered the notion of putting a virtual machine on a computer and renting you compute and renting you storage and letting you go ahead and build applications, run applications on their cloud using this thing called infrastructure as a service. Well, I think we all think infrastructure as a service is very valuable. Oracle has gone into that business. But the way Oracle plans on, and is the process of differentiating itself from Amazon, is to offer a complete suite of platform services that are at a higher level than low-level infrastructure stuff. In other words, if you built an application infrastructure as a service, it's not very much different. In fact, that's the whole idea. Not very much different from you having bought a computer, gotten a VM, gotten an operating system, put up a network, and you're using those compute resources and those storage resources in your data center. Amazon said, no, do that in our data center, and the process is a little bit faster. It's easier for you to acquire compute. It's faster to acquire storage, and you're very familiar with this particular OS and this VM, and you know how it works, you know how to develop apps, and you can do it over here in our data center, in our cloud, rather than your data center, and you can save money. We do that. But that's not our strategy going forward. Our strategy going forward is to develop a high-level layer of software called Paas services that sit on top of infrastructure. So rather than developing database applications like you used to develop, you'll have a new set of tools for application development, for mobility, for integration services, for database services that are not business as usual, writing programs on infrastructure, be it cloud infrastructure or your data center infrastructure. Instead, you'll be using these very high-level services that will allow you to build applications much faster, mobile applications much faster, much more securely, much more safely than you ever could. So these autonomous Paas services basically allows your organization to become much more efficient in developing applications and running applications spend much less money developing applications, running applications, and the resultant applications themselves are dramatically more secure and dramatically faster and therefore lower cost than had you developed them the old way. And the first of these Paas services that we're going to talk about is the Autonomous database. Now, the Autonomous database is, and this is my slide, is based on a technology as revolutionary as the internet. You know, Oracle used to have a tagline, "The internet changes everything." Well, this technology, same deal, changes everything. Machine learning. For the first time, the great promise of AI, and AI was developed by a guy by the name of Josh Lederberg at Stanford University many years ago. Later on, believe it or not, he ran my medical foundation. He's a Nobel laureate, ran Rockefeller, was president of Rockefeller, the great biology research institute in New York. But believe it or not, he was the father at Stanford University of artificial intelligence. And for a long time, people looked at the promise of AI, but it never quite delivered to its promise until very recently. And with the advent of the latest generation of AI, neural networks combined with machine learning, we are doing things that hitherto have been considered unimaginable by computers. You know the applications. The applications are self-driving cars, which even though we had an accident, a tragic accident recently, should be much safer than human drivers who get in accidents all the time. We lose about 30,000 people a year in the United States to traffic accidents. All over the world, obviously, the number is much larger. So self-driving cars will not only be much more safe than human drivers, they will allow transportation services that are extraordinarily low cost. Already people are finding it easier to ride around in Ubers than own a car and drive themselves and park a car and do all of those things. Imagine when the Ubers don't have drivers, or the drivers really are computers. How much less expensive that's going to be. How much safer that's going to be. And we have every important car company in the world is working on this right now. Everyone. And they've made and a lot of companies that aren't car companies are working on it. They've made enormous progress. Computer vision, facial recognition. Most people, I think, have smartphones or tablets that you no longer log on to and enter passwords. Maybe for a while you used your fingerprint, and now even that's too inconvenient as it does facial recognition. And everyone kind of understands how that works. Has seen that application. More remarkable are cities in China where the stoplight recognizes every single person who lives in that city and every single person who visits that city and catalogs that they just crossed at this intersection at that time. Basically, it knows where you are and what you're doing pretty much all the time. And in fact, China is the leader right now in facial recognition. You can like or dislike that particular application in terms of its implication on privacy, but the technology is extraordinary. And we could have a very interesting debate about these technologies. I mean, is that technology dangerous? Could it be used for evil? Could it be used for keeping track of people, invading your privacy? Every technology has the potential for misuse. I can imagine, clearly, every technology has been, at times, misused. I can imagine back the first cave person who discovered fire. And a person that was sharing the cave with him or her, whoever discovered fire, said, I can't believe you discovered fire. We can't let the secret get out. People can misuse the fire for all sorts of terrible things. People can be burned. But no, we're just going to cook food and protect us against wild animals, heat up the cave in the winter. No. That's true, but this is terrible. I know, people are going to do horrible things. Someone's going to be burned at the stake one day. And there was this huge debate. Well, airplanes, every technology can be used. But by and large, technologies have improved our lives and lengthened our lives, made us more healthy, helped educate us, and generally have improved general welfare and prosperity. Of course, any technology can be misused. We are using machine learning to make our software smarter, to make our software self-driving. Okay, a 2-minute tutorial on machine learning. What machine learning does is it learns kind of like people learn. It learns through experience. It learns by inspecting large quantities of data. Just like little kids look around the room, constantly processing lots and lots and lots of data. They listen to people, people talking to them, and eventually they also learn how to talk by understanding and repeating patterns that they're hearing. Machine learning kind of works the same way. They look at large amounts of data, and they detect patterns in that data. So the very first thing machine learning ever detected was a cat. It was looking at a lot of visual information, and eventually it said, I've seen that before. And it was a cat in a picture. So gradually distinguishes one kind of object from another kind of object. It distinguishes normal patterns in the data from anomalous patterns in the data. So if you teach a computer to look at cells, a lot of blood cells, the computer can say, well, that's a normal red cell, that's a T cell, blah, blah, blah. It's going through all of this. And then it will detect a cell that it kind of hasn't seen before, or it's very rare. And that, in fact, they know it's an anomalous cell. In some cases, in certain kind of patterns, they know it's a cancer cell. Similarly, if you process computer logs, and you look at lots and lots of login data, and it turns out that your CFO is always logging in from Palo Alto, where they live, or Redwood Shores, where they work, or New York, where they're visiting and giving presentations, or London. But it was really strange when they logged in from a village in the Ukraine. That's an anomalous piece of data. Maybe we shouldn't allow that login. So we can make our computer systems much more secure by having automated, intelligent detection of anomalies, anomalous logins, or other anomalous things. Another example, when you write an Oracle application, especially an analytic application, you end up sending the database queries to ask this question and that question. And if all of a sudden the system sees a query, unlike, that doesn't look anything like a query they've ever seen before, like, even if it's not about social security numbers, even if it's not kind of an obvious attempt to steal someone's identity. It's just a SQL query they've never seen before. You flag it, you look at it, it's an anomaly, and it might be some attempt to break into the system. But this is all now. But now this is all automated. This is all automated. This intrusion detection into your computer system must be automated, because if cyber criminals and cyber terrorists are using networks of computers, botnets, networks of computers, to attack our computers. And we think our human beings can form a defensive wall against these computer attacks. We are dreaming. It has to be our computers versus their computers, or we have no chance. So we make this huge investment in automating our cybersecurity systems using machine learning, detecting anomalous events, so we then can respond. This is, by the way, a very big deal. I would say the Oracle Autonomous Database is probably the most important thing we have ever done. And it's very different from what other people are doing in the data management industry. And it's desperately needed because one of the very, very worst things that goes on in our industry is data gets stolen. Personal data gets stolen. There's massive fraud. And okay, your credit card gets stolen and someone charges a bunch of things against your credit card. That's bad. That's very expensive. Much worse is when nation states steal all of this information and use it to undermine our essential infrastructure, discover who our intelligence agents are around the world, et cetera, et cetera. And that's happened. And that has happened. The Office of Personnel Management, federal government, big federal office, lost all of its applications, all of its security applications were stolen by a state actor that allowed them to detect most of our intelligence agents in our embassies around the world. So we need automated systems, intelligent systems to protect our data. First thing we have to do, again, is detect an anomalous event and do that in an automated way. That is necessary but not sufficient to protect ourselves. To protect ourselves, we have to then block any intrusion. We have to detect the intrusion, the attempted intrusion, and then you have to block the intended intrusion. And one of the unique things about the Oracle Autonomous Database is once an intrusion or a problem has been detected, the system can automatically patch itself with no human intervention. Once a security flaw has been detected, the system will automatically patch itself, and that vulnerability will be closed off without any scheduled downtime, without any human intervention. Note what happened at a credit agency recently that lost a lot of data, had a lot of data stolen. They knew about their vulnerability for months, and they actually attempted, the vulnerability was in a data management system called Apache Struts. They detected there was a problem. It was published that there was a problem. They tried to find all instances of Apache Struts that they had. They found 80% of them. They patched 80% of them 6 months later after the vulnerability was detected. Unfortunately, the other 20% were not detected, and they lost vast sums of customer data. As a result, the company management was discharged, and the company lost a tremendous amount of value. But the worst problem is people, lost, suddenly had their identities were vulnerable. Now we know that data was not stolen by fraudsters. Great thing is cyber criminals did not steal that data. How do we know? Because the credit cards never showed up on the dark web. That means nation states took the data. They're not trying to, just steal your money. Okay. The Oracle Autonomous Database is 100% self-driving. It is fully autonomous. It needs no human intervention. It will provision itself. It will tune itself. It will patch itself. It will upgrade itself. It will add storage. It will add compute. It will delete compute. It will do all of that without human intervention. It is 100% self-driving. The automated cyber defense is, I wish we could say we had 100% automated cyber defense. We're constantly putting more and more information into our cyber defense, but it still is a combination. It still is a combination of human beings and machine learning. Okay. There are lots of benefits to autonomous systems. The first one is the elimination of human labor. I mean, obviously, there's an enormous cost savings to saying that a lot of things we normally thought of as database administration is now handled by the computer. It's now fully automated. There's again, what I said, provisions, upgrades, patches, tunes, does all of that, expands, contracts. There are no fixed configurations you have to pay for. This is very different than Amazon. You know, it's interesting that Amazon calls itself the elastic compute cloud. However, if you look at Amazon's database, two databases, Redshift and Aurora, can they automatically expand as you need more capacity? Do they automatically get bigger when you need more capacity? No, not elastic at all. You have to shut the system down, deallocate the storage, move the data from point A to point B, get more compute capacity, then bring it back up. That's very different than if you need more compute capacity or more storage with the Oracle Autonomous Database. You just say, add storage, add compute, and it just does it automatically. We're elastic. They're not. You pay for a fixed configuration, and you have scheduled downtime if you want to change it. But this no human labor is a very big deal. It's a very big deal because human beings make mistakes. Pilots make errors. Almost all airline crashes are pilot error. Not a problem with the airplane. Human beings make mistakes. Some human beings who you think work for you work for themselves or somebody else. Human beings can be malicious. You have you're a large bank or whatever, and you could have people working for you who are not working in your best interest. Some people can be malicious. And if you get people out of the database administration business, that's a less opportunity for human error and eliminates the possibility of malice, someone intentionally doing something to sabotage your systems. So getting rid of, and by the way, the vast majority of the cost of running an Oracle database, or any kind of database for that matter, is human labor. It's not the cost of the disk storage. It's not the cost of the compute. It's not the cost of the flash storage. It's not the cost of the network or the interface cards or anything else. It's people. People are the source of the costs, and people are the source of almost all the errors. Okay, we have, because the Oracle Autonomous Database is fully automated, we can guarantee, our SLA guarantees, we will contractually guarantee 99.995% uptime. And that includes everything. That includes upgrades, patching, everything. That's a couple minutes a month. We'll be down. There's nothing close. There's nothing close to this. As I said, with Amazon, you just want to add more storage to your database. You want to add another processor to your database. You have to shut the whole thing down. You want to patch it, you have to shut the whole thing down. You want to do an upgrade to shut the whole thing down. Plus, the system always, not only is the tuning of the system fully automated, it's continuous. One of the great problems with databases, by the way, including the Oracle database, historically has been when you built the application, you loaded your data, and then you tuned your database. You added indexes, you created partitions, you did all of these things to get it running just so. And then you went off and worked on your next project. In the meantime, the data distribution in your database changed. The database got larger. You got a lot of historical data in it. The database kind of changed its shape. It changed, it changed its size. And all that clever tuning that you did 18 months ago is no longer optimal. The database performance isn't good. The database hasn't been tuned for 18 months. It's been running for 18 months, but it was tuned once in the beginning. The great thing about the Oracle Autonomous database is it's constantly collecting these logs, it's constantly learning, looking at queries, it's constantly looking at results, and it's constantly tuning itself, creating indexes, dropping indexes, creating new partitions, doing all of these things with continuous tuning. This leads to a huge savings because we consume fewer resources because of this continuous tuning, because of this automated tuning. What Oracle does is guarantee if you take a workload from Amazon that's running at Amazon, either on an Oracle database at Amazon or on an Amazon Redshift database, and by June, Amazon Aurora database, and you move it to the Oracle Cloud, and we guarantee your bill from Oracle, just your cloud bill, nothing to do with labor, nothing to do with anything else, just your cloud bill, we'll guarantee it's less than half of what Amazon's charging you. Just because our database is the autonomous database is so much more efficient. We compress the data, we use less storage. We have better algorithms. We use less compute. There's no magic here. You say, well, Amazon charges and Oracle charges essentially the same thing for storage and the same thing for compute. How could you be less than half the price? I've looked at your prices, and they're exactly the same. It can't be true. Well, if Amazon charges by the minute, and we charge by the minute, and we do in 1 minute, what it takes Amazon 5 minutes to do, Amazon is 5 times more expensive than we are. And that's pretty much, as you'll see with the demonstrations about to come up, that's pretty much what the ratio really is. On an Oracle database, running an Oracle database at Amazon will cost you 5 times what it costs you to run in the Oracle Cloud, because it will take you 5 times longer. You'll use 5 times more resource, 5 times more compute at Amazon than you will use at Oracle to do the exact same thing. And we've tested it over and over again. And we've invited other people to look at our numbers and look at our tests, and if they can get better results for Amazon than we're getting, we'll publish your results. But it's 5 times more expensive to run an Oracle database at Amazon than at Oracle. And by the way, running a Redshift database at Amazon versus an Oracle database at Oracle, almost 10 times more expensive at Amazon. Okay. And of course, and that's not even counting the labor savings by automating the DBA function. That's not counting the cost of downtime that we have 99.995% uptime, dramatically better than Amazon. We have no cost for downtime because we have essentially no downtime. We have no cost for database administration because it's completely automated. We're not even counting that. We're just taking the Amazon bill and saying that's by itself is 5 times higher. All right, the Autonomous database is a combination of things. We've taken Oracle 18c, the latest version of our database, and added a lot of features to Oracle 18c. We've put it into the Oracle Cloud. The Oracle Autonomous Database, it turns out, runs entirely on Exadata infrastructure. So it runs on this purpose-built infrastructure that's very, very fast. We compress all the data storage. We have a very fast interconnect. We do all of these things. But suffice to say, running on the Exadata infrastructure is way cheaper than running it on the Amazon infrastructure. And then we have automation driven by policy. So you tell us when you set up a database whether that's a test dev database. It's test and development. You don't need 99.995% availability. So don't give me disaster. I don't want to pay for disaster recovery. I don't want to pay for this or that. I want to optimize on cost, not availability and reliability and recoverability, in that case, for test dev. This is a major production database. I want to guard against every failure. I want to guard against, even if your data center goes down, even if there's a fire in your data center, I want to, you've got to cover everything. This application can never go down. I want the 99.995. So you can optimize for lowest possible cost. You can optimize for the highest possible availability. You can optimize for the highest possible performance. You can do combinations thereof. But you just tell us what's important to you. And we will, based on those policies, we will then do all the tuning, create the indexes, create the fail-safe copies with active data guard in other data centers, in other regions for that matter. We'll do all of that in an automated fashion. Okay, Oracle 18c has lots and lots of cool features in it. Again, it's now generally available in our cloud as part of the Autonomous Database. We put in lots of OLTP features, lots of, all of our in-memory stuff just keeps getting faster and faster and faster. That's not what I'm here to talk about or emphasize today. Again, we put a lot of features into this, but the big thing we've done here are the new machine learning algorithms, the ability for this thing to run autonomously in the public cloud, and by the way, in what we call clouded customer. So you can get this both in the public, in the Oracle public cloud, or you can get this in your data center, where in something we call clouded customer, where we actually take an Exadata machine and what's called an Oracle Cloud machine, and we actually build a portion of our public cloud, if you will. We put a portion of our public cloud behind your firewall in your data center, if you want that. We give you the option. All right, I've got very strict data privacy rules here in Switzerland. I'm a bank. I'm not allowed to move my data outside the country. So I'm not moving it to Oracle. I'm not going to move it to your data center. But I want to take advantage of all these features of the Autonomous Database. So I want this capability. Okay, we can actually take, and it really is it's the exact same hardware and software that runs in our cloud, our public cloud. We'll take that and build like a little mini part of our public cloud behind your firewall. And then we can run our Autonomous Database behind your phone. And by the way, you pay for it exactly the same way as you would pay for it if it was in the public cloud. So it's still subscription. We still manage the database for you. It's still autonomous. It's a joint responsibility, if you will, for managing the database. We have some responsibilities and you have some. You develop the applications, you update the applications, we back up the database, we tune the database, we meaning either Oracle people, but more precisely Oracle software does all of that. So there are a couple of ways of the way we deliver this. And again, this is the biggest issue with what autonomy means. Autonomy means no human labor. Driverless cars, no human labor, no human error, no human cost. Okay, I'm pressing the button. There we go. All right. I've said this already, the continuous adaptive performance tuning. This is actually a very, very big deal. Anyone who's a professional DBA knows that periodically you have to go back and tune these data warehouses. The shape of the data changes, the size of the data, the amount of data changes. The kind of queries people are asking change. The kind of analytics people are doing change. These applications evolve over time. And they put different strains on the system. So how you tuned it 3 months after you built the application is very different than how it needs to be tuned 3 years after the application has been running. We do it continuously. It saves you money. Okay? Next slide, please. There we go. One of the two would work. Okay, I mentioned this earlier, this dynamic elastic hardware allocation. This is a very big deal. In Amazon, if you want to make Redshift bigger, add another computer, add another processor, more compute, more storage, shut the system down, move the data. You can be down for days. Here, throw a button. Now, full disclosure, right now our elastic hardware allocation, we actually have left it in your hands. If you want to expand the system, you throw a switch and we'll immediately add more compute or immediately add more storage. We'll do that for you automatically, I think, starting in the summer. But right now, the first version of the Autonomous Data Warehouse, which is out right now, it has all this elastic capability. You can add compute, you can add storage, but you have to throw a switch. We will do that by policy sometimes by the summer. But again, this is very different. Even though you throw the switch, there's no downtime. We're just waiting for you to tell us you want more performance, you want more capacity, you want more storage. And we immediately add that capacity without any downtime. So the irony is the Amazon Elastic Compute Cloud is not elastic, but the Oracle Cloud is. And this is very, very important because the whole idea of, the great thing Amazon says is, you kind of get what you pay for. You get what you use. Well, that's just not true. If you have fixed database configurations and you have to define your configuration once, and then that's what you pay for. You can't make the configuration larger at the end of the month for peak loads and make it smaller in the middle of the month for less load. You don't get what you use. You get what you allocate. You have to scale it for maximum usage because it's so expensive and time consuming to take the system down and add capacity. Ours, you actually can, if there's a lot of demand, add capacity. If there's less demand, reduce capacity. Just throw a switch. In our case, it is true. You pay for what you use. That is not true at Amazon. All right, there is a lot of stuff built into the Oracle 18c database that allows us to do some things which must seem like magic because no one else does them. We have a fault-tolerant configuration. That means if a computer fails, the database keeps running. We have this thing called real application clusters. That's built into Exadata. That is, if you have a fault-tolerant configuration, if you, by policy, have said, I want to minimize downtime, we give you a fault-tolerant configuration. That means you have multiple processors accessing the same database, and one of those processors should fail. You might slow down a little bit, but the system keeps running. The system never comes to a stop. That's simply not true of Redshift or Aurora or even Oracle at Amazon. You run Oracle at Amazon, you don't get that feature. You don't get the real application clustering feature. They don't support it. You don't get that. You don't get that fault-tolerant configuration. They don't have fault-tolerant configurations for database at Amazon. We also have this thing called active data guard. So if the regional data center should fail, we immediately fail over to another data center automatically with no interruption. They don't do that. I mentioned earlier that we have the ability to patch the database while it's running. Well, how could that possibly be? How can you change tires at 140 miles an hour? Well, again, full disclosure. If you're driving 140 miles an hour and you need to change a tire, you got to slow to 130. Because let's say you have 8 processors processing this database load. And what we do is we take one of them offline. So all you have is 7. So you end up with 7/8 the performance that you had before. You slow down a little bit, not that anyone would notice. And you take this one computer down and you patch the software on that one computer and you bring it back up. Then you bring the next, and you do that over and over. The computer 1 gets patched, comes back online. Computer 2 goes offline, it gets patched, comes back online. It's all based on this idea that we have multiple non-shared memory computers running the same database. We can detach one of them, upgrade the software, bring it back online. No one else has any of this stuff. Can't do it. They don't have fault tolerance. They don't have rolling upgrades. They can't patch without downtime. They don't have automated patching. None of it, they don't have any of it. Not even when you're running Oracle at Amazon do you get those features. You certainly don't get them with Redshift and Aurora. You can even go from Oracle 18c to the sometime in the future delivered Oracle 19 or 20. And you can actually do those upgrades without downtime. Even in the case of a malicious user deleting lots of other users from the system, not a problem. We have this thing called flashback, where we can go back in time to before that user deleted all of that information maliciously, and we can recover it, all without taking the system down. Okay. Guaranteed 99.995 reliability. We will put that in our contract. We will put it in our contract, and we will pay you if we miss. And there are no exceptions. This isn't 99.5, but not counting when you have to take the system down for patching. Well, you don't have to take, it counts everything. Very simple. What are the exceptions? What's the downtime that's not counted in that calculation? All downtime is counted in that calculation. Amazon is very different. Amazon has a long list of things they don't count. Amazon claims to have 99% availability, but you can't count downtime for patching. That's not part of the 99% calculation. What about for upgrades? Oh, no, not for upgrades. Well, what if you need to add more storage? No, that's downtime for storage. That's downtime for configuration change. We don't count that as part of the 99%. What if Amazon's doing its own software upgrade? No, that's not counted as part of the 99% calculation. What is counted? Nothing. So, I mean, it's pretty funny when you read this list. Anyway, the autonomous data warehouse is now available to all of our customers. Fully automated, highly efficient. We guarantee you no human labor for database administration, elastic configurations, and bring in your Amazon bill, we'll cut it in half, guaranteed. 99 and dramatically more reliable and secure than Amazon. All right, so that brings me to a series. It's actually, this is not the the demo someone else is going to do. This is kind of a bunch of demos I did at Oracle Open World that I just want to recap to show you how we compare with Amazon when you're kind of running Oracle at Amazon versus Oracle, I'll do this very fast, versus Oracle in the Oracle Public Cloud, the Autonomous Database in the Oracle Public Cloud. All right, let me just go to the next slide. Oh yeah, the cost. This is a very low-cost service. So the great thing about the Oracle Autonomous Database is our customers can use their existing licenses. You don't have to buy new Oracle licenses. You can use your existing Enterprise Edition licenses and bring them to our cloud. And reuse those licenses, the same licenses you bought for on-premise use. You get to reuse those licenses in our cloud. And you can reuse your Enterprise Edition license, you can reuse your RAC license, you can reuse your Active Data Guard license, you can reuse all of that stuff, no additional cost. The only thing you pay for, if you bring your own license, the only thing you pay for is the infrastructure, the compute capacity and the storage. And that's it. And that's the cost of compute and the cost of storage, the incremental cost when you bring your own license. And you can get started for $272 a month. So we think it's a very attractively priced service, considering it's fully autonomous, very reliable, very secure. Okay. I mentioned earlier, we have a whole bunch of autonomous services scheduled for this year. The Autonomous Data Warehouse is the first one. It's out now. We'll have the autonomous version of our OLTP database, kind of the other half of Oracle, data warehousing and OLTP. We'll have that out in June. So we'll have the two main Oracle services out by June. On top of that, we have other data management services, the Express database and the NoSQL database. But we're not stopping there. We're building a complete layer of autonomous services. Our autonomous analytics service is coming out this summer. So when you have an autonomous database, you then pair that up with autonomous analytics and visualization. We have an autonomous mobility service for mobile applications. We have an autonomous developer service. We have an autonomous integration service, if you will. And so Mark Benioff just spent a lot of money for MuleSoft to get MuleSoft integration services. Good company, nothing wrong with it. But it's kind of a last generation company. These are not autonomous services that MuleSoft offers. It's kind of conventional, old-fashioned way of plugging things together. Things in the public cloud to things on-premise, they can do all that, we can do all that. But our new version of integration services are autonomous. They're autonomous Paas services. This is a whole new layer to the cloud of highly intelligent services for data management, application developers, including mobile application developers, including development of analytics, including the integration between your modern cloud systems and your existing on-premise systems. All of that is now going to be available in the summer as autonomous Paas services. This is how we plan to compete with Amazon. Yes, we have infrastructure as a service. We think we have better infrastructure. We think we have faster infrastructure, more robust infrastructure, blah, blah, blah. But what's highly differentiated, which is fundamentally different from what they do, are these autonomous Paas services. They don't have anything like that. MuleSoft doesn't have anything like that. This is a unique, no one has anything like the Autonomous Data Warehouse or the autonomous OLTP Oracle database. And remember, we've been working on this problem, this database problem, for 30 years. We've been working on this for a very, very long time. So our database, it's an in-memory database. It's an object database. It's a relational database. It's an IoT database. It does all of these things, and now it does them reliably. It's a fault-tolerant database. And now it's a highly secure database, and now it's an autonomous database. So this is highly differentiated technology. All right. I think I've said all of this. Automated upgrade, patch, tune. Minimize the computer resources we use. Therefore, it's very, very low cost, very reliable, very secure. All right. I'm going to just skip through this, or we'll be here for dinner. OK, this is Oracle at Oracle versus Oracle at Amazon. That's my first set of slides. And my second set of slides will be Oracle at Oracle versus Redshift, Amazon's data warehouse at Amazon. All right. This is just saying how bad the Amazon offering is. It's not automated. It's not efficient. As you say, it's not elastic. You have to have a fixed configuration. You max out your fixed configuration. You pay for it when you don't use it. They don't compress the data, blah, blah, blah. It's not reliable. It's not fault tolerant. It's labor intensive. There are lots of human errors. It's very expensive. All right. This is the thing. This is a partial list of Amazon claims 99% reliability, except for all this stuff. Doesn't include downtime for capacity, doesn't include downtime for maintenance, doesn't do downtime for upgrades and patching, blah, blah, blah. OK. All right. So we matched up these configurations. We came up with the best Oracle configuration we could come up with. And we also came up with the most cost-performant configuration at Amazon that we could come up with. We published all these benchmarks. And we've invited people to try to do better at Amazon. And anyone who does better at Amazon, we said, we'll just publish your numbers. We'll reproduce your numbers, and we'll publish your numbers rather than ours. So this is the current state of the numbers. And these numbers have been out there since the fall of last year. And they've moved a little bit, but not much. All right. We looked at a variety of different applications, financial, marketing, insurance, and retail, all analytics. OK, the first demo, it was the Oracle database, again, in Oracle versus the Oracle database in Amazon. All right, financial workload. So here's the slide. Now we're going to start up. This was a little meter I had on the screen, a couple of computers on screen, on the stage with me, and we're running these benchmarks. And you see, after 20 seconds, Oracle's more than halfway done. Same exact workload, same exact database, same everything. We're halfway done. They're not even 10% done. I'll keep going fast. And by the time we finished, we did it in 34 seconds. Amazon did it in 255 seconds. Same exact thing. Took us 4 cents, cost 4 cents at Oracle, cost 23 cents at Amazon. Same exact workload. And remember, we're 99.995 reliable. We're more secure. We don't have any labor for database administration. They have all of that. But forget that. This is just your Amazon compute and storage bill. Just the infrastructure costs. They're almost 6 times more expensive just for the infrastructure. Another one, this is a retail workload. And to go through this quickly, after 20 seconds, we're 70% done, still not 10% done. By the time we finish, in 35 seconds, again, almost 6 times cheaper than Amazon. Same cost per minute. Same cost per minute, but 6 to 1. So if you don't want the 99.995% reliability, if you don't want the automation of the DBA functions, go to Amazon, but you have to pay extra. If you really don't want the reliability, it's going to cost you more. All right. Insurance workload, surprise, surprise, same thing. After 20 seconds, we're well ahead of them, going about 4 times faster. By the time we're done, Amazon is 8 times, more than 8 times more expensive in this particular application. But it was test after test after test. We invite all of our customers, take an Oracle database to Amazon. Try it. Please try it. You can do it. It's going to cost you a lot more. All right. Okay, so running Oracle on Amazon is much more expensive than running Oracle on the public cloud. But that's not taking into account the other benefits of labor savings, error reduction, reliability improvements, and all these other things. Security improvements. The next one is looking at Amazon. This is not the Oracle database at Amazon, but Amazon's premier data warehouse called Redshift. This is Amazon's best of the best. This is their own stuff. Well, it's not really their own stuff. It's an open source database that they closed sourced. They took it from open source and put it on Amazon, and then they said it's not open source anymore. It's now Redshift. All right, so here we go. Same financial analysis workload we did before. This is on Redshift. We see after 15 seconds, we're more than half done. Amazon's not 10% done. We go on. We go on. 9 times more expensive to run Redshift on the same. This is the same exact data, the same exact queries, same workload. And I go on. Here's the next one. Okay, more than 15 times slower to do the same thing. Well, he said, well, Oracle's always bragging about performance. Oracle's always bragging about performance. Great, you have a fast database, nice. But it's really expensive. We know that. You can't fool us. We know Oracle charges a fortune for its database. You can't fool us. Yeah, you're fast, but you're expensive. Actually, they're 15 times more expensive than we are, because they're 15 times slower, and they charge by the minute, and we charge by the minute. So this fast thing translates 1-to-1 to cost savings. It's a big deal. All right, here's another one, marketing data. Same thing after 23 seconds. We're done, they're still working. Finally, in the end, this time they're over 13 times more expensive. Again, we did so many of these tests. These are a handful of the tests. I'm going to stop right here and just say that we invite you, all of our customers, who have workloads at Amazon and are familiar with Amazon, to go ahead and try a database workload. Try one at Amazon. Try one in the Oracle public cloud. Measure 2 things. Which is easier to use? And which costs more? Which is more reliable? Just try it. And it's not close. It's not close. We are, they're 10 times more, they're between 5 and 10 times, sometimes 15 times more expensive than we are. We fully automate the DBA function. We give you 99.5% reliability. But if you want all of that, we give you automated intrusion detection, automated patching, where never again will you have to take downtime or wait for a downtime window to close a security vulnerability, like you have to wait at Amazon. Never again, that will be automated away for you. You get all of that, but you have to be willing to pay less. With that, I'd like to turn it over to the guys who are going to be doing the demonstration, and then we're going to have a customer panel after that. So please stay with us. Thank you very much.